the SageMaker approach first, and then we'll circle back to Bedrock and see what's this other way of interacting with this model there.
So for folks who are tuning in late, right? So we're looking at multiple ways to deploy the DeepSeek model
Mhm.
on AWS, and Ivan is walking us through the different deployment patterns that are available and choices that are available for us.
Absolutely. And one of the key points when you work with open source models is that you want to make sure that you follow the best practices from the security perspective. And that is something that SageMaker really excels at and helps us accomplish those goals very, very easily. So, the approach that I explored early on before the support was released directly in SageMaker Jumpstart and in Bedrock was to just go to Hugging Face directly, pull the weights from there and deploy that model into SageMaker endpoint as if it was any other model without relying on the SageMaker Jumpstart service to accomplish that. So we can accomplish that task by taking a look at those distilled models and choosing one of these models. So I've selected the Llama 3.1 AB, which again is Llama 3.1 that has been used to distill R1 onto. And there's going to be a link here from Hugging Face that will take you directly to that model, which is where you'll find all the information around how to find the model weights and how to go ahead and deploy that. So that is what I've done. I went into my Jupyter Lab app, which I just call a sandbox in my account here. And in that Jupyter Lab app, which is just a managed Jupyter environment that SageMaker provides. I've just wrote a few lines of code to be able to deploy this model, interact with it, while following the best practices from the security perspective and making sure that this model is going to get deployed in my own VPC using my own subnets, my own security groups, where I have much more control than just running this, without any of those precautions. So in this Jupyter Notebook, we can accomplish this task by first importing the SageMaker SDK as well as the AWS SDK for Python, as well as some components from the Hugging Face that make it really easy to deploy models that are hosted in that have their artifacts, their weights hosted in Hugging Face. So we're going to import the Hugging Face model, which is going to make it easy to instantiate that model, as well as this get Hugging Face LLM image URI that's going to allow us to easily use this helper function to pull the appropriate container image that can be used to spin up a container to host this model. And then I'm going to grab the model ID here. Where does this come from? Well, it comes from the Hugging Face page. So you see this part right here, DeepSeek AI followed by the model ID. That is what's used as the reference. So they even added the little copy icon here, so you can easily copy it and use it on your end. So this is where this ID comes from. And I'm also specifying how many GPUs we're going to be using. So once we import that, the next step is to instantiate that Hugging Face model. And we accomplish that by providing some information around what container image should be used and some environment variables, which is this hub dictionary that we set up earlier with the ID of the model, what role should be used for that SageMaker endpoint for any permissions that it may need, like pushing logs to CloudWatch logs as an example, as well as this optional argument for VPC config, where I get to specify my own subnets that reside within my VPC. And these subnets are going to be private subnets. They're not going to be publicly accessible. So I have much more control over who and how is able to interact with this SageMaker endpoint, including what ports and what protocols they can use to accomplish that.
So if we pause here for a second, right, and talk about the security aspect, right? So when we
Yep.
deploy this model in SageMaker and you're giving that subnet IDs and the security groups there, uh, can
Mm-hmm.
we dive into that security portion of it, right? So this model is being deployed very securely within the boundary of the AWS VPC, which is the
Right.
virtual private cloud there, right? It's a portion of the network that is separated out and in an airtight environment, and the model is deployed there, correct?
Exactly. And you as a customer, you are in full control over how that VPC is designed, what routes are in the route table that impact these subnets, what rules or security groups that are going to be attached to that instance, which rules are in the network access control list that are associated with the subnet. So you have quite a bit of a control over the environment that this runs in, which is always a great idea to a great way to explore some of these more speculative open source elements, just because you have various layers of security that protect you from potentially this starting to make some calls back to the mothership and leaking certain things in any way imaginable. So this way we have full control of the environment and making sure that we are deploying this model in a secure way. So once we have this model instantiated, we can simply go ahead and call deploy on it, specify that we want one EC2 instance, that we want, in this case, I'm using G5 2 extra large, which has the one NVIDIA A10 GPU available, which is going to be sufficient for this distilled model and any other configurations around here that's in this case around the health check timeout, because it's a larger model. We want to increase that value a bit. So once you run this, what you're going to find is that the model deployment is ongoing. That's what these hyphens are resembling as they continue to tick. This is equivalent to the model being deployed. So while this deployment is happening, we can see that the kernel here is busy. The cell is locked and currently running. While this is running, we can go back to the management console and we can take a look at what actually got created. As part of us calling that deploy function, there are actually three things that simultaneously get created in a SageMaker service. The first one is what we call a SageMaker model resource, and is going to be available in the inference section. So that SageMaker model resource is, you can think about it as a wrapper around various artifacts that are required for hosting the model, like your container, image URI, your model weights, and that is what makes deploying of models onto SageMaker very quick and very easy. So that's the first step that gets created when we call the deploy function. And we can find all sorts of configurations which should seem very, very familiar because we configured those around what environment variables we've configured previously, as well as the network details around which subnets are going to be used to host this, as well as what security group is going to be used. If we take a look at the subnet, one of these subnets, what we find is that that is a private subnet. In other words, it has no connectivity, no one from the internet can connect to those subnets. So it's these two subnets where we are deploying things onto. So this makes it really, really easy to have an extensive control over where the model is being deployed. Now, after this, there's some additional configurations around the endpoint itself that get created as part of the endpoint configurations object there. So we'll also see a new object being created here, which tracks various information around what additional features are potentially enabled or disabled, like data capture on the SageMaker endpoint, as well as how many models, how many model variants we have running, which is going to be pointing back to that SageMaker model resource that we just reviewed. And then finally, the last part, the third part that gets created as part of deployment is the endpoint itself. And we can see that we have one endpoint, which is in creating state. And in that endpoint, once it becomes available, we'll be able to see various utilization metrics around the CPU utilization, memory utilization. This instance has GPU, so we get GPU utilization metric as well as a pointer to the logs in CloudWatch logs.
So essentially, when the model is deployed and available, that's the endpoint that anybody can hit so that they can make those inferences. And
Right,
also just,
not anybody, because it's private. And
yeah,
that's the
exactly.
point, right? That's why we use the VPC, because only I can do this. No one else, right, outside of my VPC can do this, and that's the primary goal of using some of these additional configurations. Because keep in mind, you don't have to specify your VPC, your subnets, your security groups. That's optional with SageMaker, but you want to go through that exercise anytime you're deploying models, because it puts you in a better state of control.
And also talking about the security side, right? We spoke about the VPCs and the security design, but on the encryption side of things, right? So let's
Yeah,
talk about that for a second. So when we deploy
sure.
these models in SageMaker, or any other approaches that we are showing today, all the data that is stored and is in transit is encrypted using what we call as AWS KMS keys, using key management service. And you
Hmm.
can also bring your own custom managed keys, right? Customer managed keys, so that you can completely encrypt with any data that's being deployed, including the model itself, um, using those customer management keys.
Yeah, yeah, absolutely. And there's quite a bit of flexibility there. To your point, Anil, you can use your own keys that you've created through KMS, Key Management Service, or you can also like to use the SageMaker managed keys as well if you don't want to go through the process of setting up your own. SageMaker has readily available keys that be used to encrypt data at rest or data that resides in those block store volumes that the SageMaker endpoint's using, as well as any data that may potentially be needing to be written to S3 there. And then for any data in motion, TLS connection is established to make sure that that's encrypted as well.
And as we deploy the model and it's getting available, once we start hitting the model, if you scroll down a little bit, Ivan, so we're
Mm-hmm.
looking at all those operational metrics, right? So depending on how the model is performing, and if it requires more CPU, more memory, right? So that's when you can tweak your deployment script and add more GPUs or CPUs, right?
Yeah, absolutely. And you can take that one step further and you can set up auto scaling policy as well that's driven by the metric that most closely resembles utilization and the traffic that we're experiencing. So as the traffic evolves, once we deploy this, let's say for in production, we can have this automatically scaling itself based on the most relevant metrics. So if we need to add more nodes, we can easily automate that entire process.
And a little shout
Excellent.
out to my main area here with our friends, the Graviton processor that does really well working with this on the back end. For if you don't know or haven't seen the Graviton processors that AWS has, right, these things where we have these very large parallelized workloads, and we're leveraging things that are going to scale like this, like I was mentioned. It's a
Mm-hmm.
nice fit and use case with it as well, because that is compute that you're going to have that's on the non GPU side of the house for it that you can couple with it. So nice.
Exactly, and Graviton is just one of the custom chips that AWS designs and makes. On the more of the ML side of things,
Mm-hmm.
Trainium and Inferentia chips are specifically
Yeah.
designed for training and inference. You have to go a step further to compile the models to run on those specialized
Train it. Yeah.
chips because they're not GPUs; they're a different type of an accelerator, but they are very, very low cost per compute and a great option to
And
consider
Yeah.
as
deploying
well.
on AWS is, you can use those Trainium and Inferentia too. I see a shout out there, Rob.
Yeah, I just wanted to. Sorry, just as we were going through, just to it was one Yvonne to another. But shout out the speakers bring real value today. That goes to you, Evan, for everything on so far's content, like this information, things you're presenting. So I wanted to give you that shout out here before it got lost in the chat.
Thanks, all.
So, but to anyone that is watching and that's looking at the chat on any of the platform, feel free to drop any questions that you might have today as well. Let us know
Absolutely.
if you've tried out DeepSeek or SageMaker, and especially like Jumpstart that we were just going over, right? Like you covered kind of all the ease that's kind of there, right? So you don't have to go through some of the steps yourself for deploying things. If you used any of those, let us know. We'd love to hear if you've taken a chance to go through or any questions you might have as we're going through the content today. And appreciate it. So there's some other comments too. I just wanted to give you that one real quickly, but thanks. Got some insightful and thanks for what you've been going over so far. So just wanted to call that out because we'll make sure our presenters feel welcome here, and you're very welcome. So
Well, thank you. Thank you, Rob. And thank you all folks for joining here. If it wasn't for you, we wouldn't even be here doing
that is
this. So thank
very
you
true. We would just be
for
talking to
being here
ourselves.
and choosing to spend your time with us. Now, the SageMaker endpoint has been deployed. It's available. It's ready for us. And we can see that by seeing the status being service. So we can go back into our Jupyter notebook and we see that the loading bar always ends with this exclamation point that resembles the excitingly successful deployment being completed. And we can see that the kernel is not busy anymore. It's idle. So we can go ahead to the next step. So we can use that predictor object that got returned as part of deployment and we can call predict on it. We can supply some inputs. Now, this is a pretty interesting input, which is larger, 911 or 9.11 or 9.8. And the reason this is interesting is because it used to really trip up models last year. And as models are not always great at math, some models, some of the cutting edge models were tending to gravitate towards saying that 9 point 11 is greater than 9.8, which for us humans, it's easy to tell that
This,
that is
yeah, this one and
incorrect.
another question, right, where we asked number of hours in strawberry, and then the models always kept getting wrong on that.
Yes, yes. So that's something that OpenAI has also done in the earlier models, and then solved that later, where it was able to correctly count the number of hours. Some of these problems that the models get tripped up on is really interesting. Because they excel at so many other tasks, but then you present them with some relatively simple task for humans, and they just start
They
tripping
can't think
over
like humans
themselves.
yet, right? So they're getting
Yes,
closer.
yes, that's right. And one of the challenges that I potentially will be running into here is that this instance is quite small for this type of a model.
Mhm.
So the latency is going to be pretty high for this model. It may even time out and not succeed. So I'm using this just to be very frugal. But if we actually navigate to the metrics of the SageMaker endpoint, we as it starts as they start to reflect, because there's typically a little bit of a lag between the CloudWatch and the compute, we'll be able to see that the metrics are actually quite high for this type of instance here. So what we're going to need to do if this fails is we can just run it again and try again, and it should be able to finish this request. So it's really just tapping out on the resources side. But overall, what we can specify when we send these inference requests is the maximum length. So this is going to be the combination of the input and output tokens. That is the maximum combination we can reach. And then the maximum new tokens is specifying what's the maximum number of tokens that can be generated by the model itself. We refer to these as the inference parameters because you specify them during inference time, and they give you quite a bit of flexibility around how the model is generating. And if you thought that the answer would be short, it never is with R1 out of the gate unless you instruct it to try and do its best. It's because it's always doing that chain of thought. It's always thinking through how to solve the problem. So this is why the output that we get is the question here, and then it goes, oh well, and then 9.8 is larger because it's closer to 10. Wait, is that correct? Let me think again. And it goes on and on and on to talk to itself and think through how to solve this problem. In the end, it arrives here with the final conclusion that it's confirming the 9.8 is larger. Thus, the larger number is 9.8. So you can interact with the model through SageMaker service, and again, it's a pretty large model, so you want to potentially up your game on the infrastructure that is being used, which is still going to be substantially smaller than if we went with the original model, deploying it with 671 billion parameters. So this approach here that we just walked through, you can use regardless of whether model exists in SageMaker Jumpstart or not, because we're going to the biggest repository of open source models, which is Hugging Face out there, and we're simply pulling models from there and deploying them to SageMaker directly. So we don't necessarily need SageMaker Jumpstart to support a particular model in order to be able to easily deploy it on SageMaker service. So now that AWS supports R1 in SageMaker Jumpstart, this approach you may not always decide to take. But hey, tomorrow there's going to be some other model
So
that's
guys,
not
this
available in
video
SageMaker
AWS
Jumpstart,
show
and you can
and
take
tell
this exact
generative
approach to deploy
AI
anything.
S1 even
And
dive
that's the nice
deep
part, right?
on
This is
DeepSeek.
while we're specifically covering it for
Okay,
DeepSeek, like you mentioned.
this
Exactly.
video is continue.
Tomorrow there could be something different.
Watch.
Exactly.
So yeah,
Tomorrow it'll be R2, and
right.
that will not be supported. So it's an effective approach to do what you need to do regardless of what's supported within SageMaker Jumpstart.
It shows like the flexibility, right, of the service in itself, just the ability to be able to leverage these and get what you kind of need into it to do what you want to do.
Mm-hmm.
So nice flexibility and capabilities there.
Yeah, absolutely. And the second approach also doesn't necessarily care whether a model is supported within Bedrock and SageMaker, because it's going to rely on importing of the custom models into Bedrock service, and that's going to be very frequently useful for us because many of these models that get distilled, they get what is used to perform the distillation on top of is some sort of very common architecture like Llama or Mistral, and that those sets of architectures are supported for importing models into Bedrock. So there's a page in the documentation that specifically walks through how you can import a customized model into Bedrock, and you can see this feature is currently supported only in two regions in US West 2 or Oregon region, and US East 1 or Northern Virginia region. And specific model architectures are supported. So the model has to be based on the Mistral, Mixtral, Flan, or Llama models in order to be compatible with this import feature. So we just talked about how the R1 was distilled onto various Llama architecture, which is going to mean that it's going to be very easy for us to import that
Mhm.
distilled model.
So this is the second approach we are looking at, right? So this the first approach
Yes.
is a SageMaker, and the second one is to be able to use Bedrock and the custom model import feature that is supported for certain architecture types.
Exactly, exactly. And unlike with SageMaker Service, where we used a particular Hugging Face model class, which during the deployment was dynamically pulling weights from Hugging Face, with the custom model import in Bedrock, you need to have weights available in S3. So I went ahead and I cloned the repository that has the weights, and I went and uploaded the weights in S3 into one of my S3 buckets so that I can instruct Bedrock to just import the model from there. So you have an extra step involved there. You can follow this process with the SageMaker as well. In fact, it may even be desirable to load the weights into S3 first and then perform the deployment, because what that would also allow you to do is to enable the network isolation mode of SageMaker service, where SageMaker basically locks any requests that are heading out of the outside of the VPC and outside of those containers to be blocked. So that approach wouldn't necessarily work with what we walked through earlier, because we're pulling during deployment, pulling weights from Hugging Face. So that connectivity needs to be in place. But if we went just like we did with Bedrock and loaded the weights into S3, we will be able to use something like a VPC endpoint for S3 to be able to just pull the weights and deploy the model without having to open up connectivity regardless of how controlled it is. There will be no connectivity out to the internet whatsoever. So using Bedrock service, we can go to in the foundation model section to the imported models. And you can see that I have one model imported, but how would you actually go about and do the model import? It's very easy, very straightforward. I can just walk you through the steps here. You would give it some name just like I did. You can choose VPC settings. So again, you have control over how and where this is deployed. Give that import job, which is going to be a batch job, some name, and then proceed to specify where the model weights reside in S3. And this is where I would specify my S3 bucket that contains the weights of this distilled model. Aside from that, like Anil mentioned earlier, with in the SageMaker context, you do have quite a bit of control around which encryption mechanisms are being used, regardless of which of these services you're utilizing. And you can also specify your own role that has the minimum permissions that only perhaps allows the import of models from that specific S3 location, S3 prefix, and not much more than that. And that's it. You would just select import model, and you will have to wait for that import job to complete.
So the model is going to be imported from S3 into Bedrock, right, being hosted by the Bedrock service and ready
Yes.
for inferences.
Yes, exactly. And once it's available, we'll be able to see that it's available by this job, a list of jobs here completing. So I've completed this a few days ago, so we can have a pre-baked demo here. We don't have to wait, because this process can take
Mhm.
10 to 15 minutes to complete. And we can take a look at the model interacting with the model itself. So I'm going to select the models here. And if I expand these three dots, here, there's an option to open this in the playground. Now, keep in mind, you don't need any provision capacity, provision throughput to interact with these imported models. They are there. But if you don't purchase provision throughput, the Bedrock is not going to have this model immediately loaded and available for you, because it's a serverless service. You're going to need to interact with it to give it a signal that you want that model to be available for us to interact with, and then on the subsequent request, by Bedrock would have that model loaded in. If and that is totally okay for experimentation. But in production use cases, if you want to make sure there's always some sort of capacity available for a given model of your choice, you would just go ahead and purchase the provision throughput, which would have that guarantee that there's at least some capacity available in Bedrock. So we can take this same prompt that we sent through SageMaker and we can send it through Bedrock as well. So if we send this prompt here, we may get a message that saying that the model is not available in Bedrock just yet, and here it is. It's not ready for inference. Again, why is it saying that? Well, because it's a serverless service, so you get a cold start, if you will. No model is available yet because I didn't purchase any provision throughput in order to keep this very cost effective for
Hmm.
myself. So I'm going to wait for just a few moments as Bedrock is now behind the scenes loading this model, and then I'm going to send that prompt again. And as I continue to prompt it, the model will be there. It'll be highly performant. It just needs to be loaded into the resources of Bedrock service so it can interact with it. And then if some time passes by that I'm not interacting with the model, again, Bedrock may behind the scenes unload it again, just to be frugal with how the resources are being utilized.
It is really handy though, just to call it like the playground itself, right? Like being able to
Mm-hmm.
leverage and quickly import and be able to play with those without having to really do anything, right? Like just by having the
Yeah.
model imported, like it's a nice little feature within Bedrock just to be able to go and play with things, just to see, just like you're doing here, right? Like how that works.
Mm-hmm.
And with this approach, right? So you've also shown, you also mentioned that there is like the model is being, the weights are being copied to S3. So what
Yep.
did that process involve, right? So is it like you had to copy them from Hugging Face? So what did you have to do there?
Yeah, yeah, absolutely. So I went to the Hugging Face page, and if you go on these three little dots on their page, you can clone a repository. So as you clone a repository, you need to have actually they show a few requirements. You need to have Git LFS set up, which is specifically designed for really large files, and these are certainly going to be very large files. It's going to be about 14 or 15 gigs in size that this the distilled model takes up. So Git LFS is going to ensure that we can pull those really large objects. And as you're cloning the repository, you're going to have those weights in the safe tensor format. Safe tensor format for serializing the models was created by Hugging Face, and it was designed as an alternative to some of the previous formats that we've serialized the weights in, like pickle format that has known vulnerabilities where as part of the model loading, some of the code can be inadvertently, malicious code could be potentially executed without us realizing. So safe tensors format went through the lengths of eliminating that potential threat, while at the same time making the whole process of serializing and deserializing models much more efficient than it was previously with the pickle format. So it's as simple as just cloning a repository, pushing, copying those model weights into S3, and then kicking off that Bedrock import job.
Excellent.
Okay, so let's go ahead and run this again, which is larger. And again, it could take some time to load this again. It's going to keep asking us to try a request again. And there's no designated amount of time in the documentation itself that this may take. So when I was working with this earlier, it took maybe about 3 to 4 minutes. Now it may take 5 to 6. It just really depends. In a similar fashion to when you interact with the Lambda functions, if you've used Lambda service before, if you don't interact with Lambda in some time, you may experience a slower start, greater latency with that first request. Now, Lambda functions are pretty lightweight components compared to these monsters right here, which are really,
Hmm.
really large. So it takes much more time uh, to set up a warm start for some of these really large models than it does for a small Lambda function that maybe has 128 megabytes of footprint, memory
Eh,
footprint.
Yeah, and if you're experimenting, this approach works. But if you're an enterprise and you want to have your model readily available, that's the approach where you get provisioned throughput,
Hmm.
and then the model is always available. It's warm, it's ready to serve and to provide the responses for all the inference requests.
Yeah, exactly. And the error message here points us directly to the documentation that where it talks about the this particular issue. So I'll paste that in the chat here for you folks, as well as this Hugging Face page that of the model base model itself. So I'll go back here if you folks would like to explore this in a bit more depth. And then if you decide that you like to explore more how the model import does works and what are the supported architecture, I'll include that link in the chat as well. Now, finally, when it comes to the new approaches of hosting R1 directly through Bedrock Marketplace and directly through SageMaker Jumpstart, this blog post is going to do a really good job with the walkthrough of how that can be used and how that can be set up there. So let's just maybe another time go back here since we have just a few minutes left and run this and see if it goes through. Perhaps it's not loaded. It also depends on what time of the day you're interacting with
Yeah.
Bedrock, since there's sometimes bigger strain on the service at certain times of the day.
Yeah, and just to add, we have seen two of the approaches today, right? So there are two more approaches
Yes.
at least. Like one of them is to directly leverage the chips, right? So the Inferentia chips and Trainium chips to be able to deploy them on those, on the EC2 instances and then use those chips. But that's when you want to really host that big model. And the other approach is to utilize EKS, Elastic Kubernetes Service, and really
Yes.
utilize the EKS to deploy those models and make it available.
Yeah. And while Anil was talking about AKS, Bedrock felt self-conscious, so it was decided to work here. So, here it is. I just said, "Let me think." Actually, I'm able to think now, so it was able to think and generates the response. You can see it's pretty quick. In
Hmm.
Bedrock, you also get some latency metrics and the counts of tokens input and output as well, which are can be interesting when you do
Yeah.
model evaluations.
Yeah. Yeah.
And now that the model is available, right now we can keep asking
You
questions
could,
anyways.
yeah.
Exactly.
You could
Yeah.
keep
Exactly.
asking it other things. Only unfortunately, we're pretty much out of time today already. Like you mentioned, what we talked before, right? We're like, oh, we'll get started. We'll go and see how long it takes us to get us through an hour with stuff. And we blew through today's hour very quickly because we had a lot of stuff to cover, right? Just a lot of interesting things between, like I said, using SageMaker, Bedrock, like the configuration, the import process, all the different things that go along with it, which today we're all really primarily going on to DeepSeek, but as you mentioned, can be used for other models as well, and for helping you leverage it in the longer run thing. So I'm thank you for everything. Really appreciate today's content. Thanks, audience, of course, for joining in today and asking. We had some comments and things in the chat. Always appreciate those and some different questions. We didn't get to one of them on isolating. Well, you kind of did because you covered it in the infrastructure as far as deploying things into a VPC and security groups for isolation of the traffic and what it talks to, S3 endpoints and stuff. But we didn't get to answer the full question that we had in the chat. So, in any case, we appreciate the questions and everyone coming to join and listening today for a little bit of AWS show and tell generative AI for this episode. So, Neil, I don't know if you have anything else. We've got 1 minute left to close out today.
Yeah, we're going to link some resources down in the description below and make them available for you from the chat today. But with that said, thanks for tuning in. And
Thanks so
uh,
much, all.
yeah.
Yeah. Thank you, man. Appreciate it. Thanks all for